Let's continue our study of logical operators by looking at an OR statement. English and Java are very similar. Obviously, English usage inspired Java, and so the words can mean very similar things. An example of this is the AND operator and the NOT operator. Now, Java is a little more precise than English is, but basically they mean the same thing. But English and Java can be very different. An example of this is the word static. Now, we've seen the word static all over Java programs, public static void main, but we really haven't discussed what it means. What I can tell you is it doesn't mean anything like what the English word static means. Another example of a word that's different in Java than it is in English is OR. So let's talk about AND first. When we say, I'll go to the movies and I'll go to the store, it's only true if you do both things. Now that's true in English, and it's also true in Java. So AND works exactly like English and Java. OR is a little bit more complicated. If I say, I'll go to the movies or I'll buy milk, the English usage is actually not completely clear. People figure out what it means from the context. Now, that kind of behavior is okay in human language, but would never be able to work in a computer. So most of the ORs in English are what we call exclusive ORs. And what that means is for the statement to be true, one or the other has to be true, but not both. The thing is, though, English is inconsistent. So suppose a retailer asks you the following question on a web survey. And by the way, I took this example from a real web survey that I filled out last week. They ask you, where do you shop for our brand? In the store or through the catalog? Online or through the catalog? Online or in the store? Well, in this case, they clearly mean that to be an inclusive OR. That is, if you shop both in the store and through the catalog, that first choice would actually be true. So this is probably an inclusive OR. But once again, these things are hard to figure out in English, and English isn't very precise. Now, when you're dealing with programming with the Java OR, programming languages have to be consistent. And the Java OR is an inclusive OR. So what that means is if we take the statement x%2 equals 0, remember that's a fancy way of saying x is even, or x%3 equals 0, which is the fancy way of saying x is divisible by 3. It's true for numbers that are divisible by 2, otherwise known as the even numbers. It's true for numbers that are divisible by 3, and it's also true for numbers that are divisible by both 2 and 3, otherwise known as numbers that are divisible by 6. And of course, if you have a number that's not divisible by 2 and not divisible by 3, this statement would be false. So that's an inclusive OR. Let's talk about exclusive ORs in Java. Suppose we want to find if an int value is outside of the range from 1 to 100, inclusive. Now, this is actually an exclusive OR because there is no single value that's less than 1 and bigger than 100 at the same time. The thing is, inclusive OR works just fine here. We can say value less than 1 or value greater than 100. The fact that these two statements can't be true at the same time really doesn't matter at all. It's immaterial. Now, very rarely will we need an exclusive OR operator, although there are some rare examples. Let's think about cryptography. In cryptography, you need to sometimes find numbers that are not a multiple of two other numbers. And so in that case, we might want to know if something's a multiple of 2 or 3, but not a multiple of 6. Now, this is kind of a hard explanation to give because we don't really know much about cryptography yet. But trust me, this is a real problem. Just the numbers aren't 2 and 3. They're bigger numbers than that. Now, you could use a conditional statement to look for the case when both of these statements are true. And that's actually the most efficient way to do it. Java does, in fact, have an exclusive OR operator. Its symbol is a caret. A caret looks like a little hat. There's one in the PowerPoint for you. But it works slightly differently, and the slight difference is really beyond the scope of this class. The sort of colloquial name for this is XOR, for an exclusive OR, which means that one or the other is true but not both. Let's take a look at the code for the cryptography example. We have public static Boolean divisible by 2 XOR 3, int value. So what this is supposed to do is take the parameter value and determine whether it is or is not divisible by 2, exclusive or whether value is divisible by 3. So first we'll create a variable divisible by 2, and we'll give it the value of value %2 equals 0. In other words, divisible by 2 will be true when value is even. Then we create another Boolean called Boolean divisible by 3, and it's going to get the value of value %3 equals 0. In other words, it will be true when value is divisible by 3. Now we're going to have to do two separate tests, one to look and see if they're both true, and in that case we would return false. So that's that first conditional statement there. If divisible by 2 and divisible by 3, we return false. Now, once we've done that, then we can use our regular inclusive or. So we'll say if divisible by 2 or divisible by 3, return true. Now, something that's very important here is to realize that the order of these if statements is absolutely essential. You have to check for both of them first. You have to use the and first, and then the or. Because if you use divisible by 2 or divisible by 3 with that inclusive or, and you do it first, you'll return true when you should be returning false. So that would be a serious problem. So keep programming.